Okay, today I want to do a whistle-stop tour of this topic in the Edexcel GCSE Computer Science. So it's 3.2 software, and this is also called SLR2 if you're using the Craig and Dave terminology. Now there's a lot here. Some of it's reasonably straightforward, some of it's a little bit more confusing. So software can be split up into system software and application software. The application software is basically the programs that run on the computer that are designed to carry out a task like email or word processing or browsing the web or playing a game. The other branch of software is system software. Chiefly among of that is the operating system, and then you have a range of small utility programs which we'll discuss in another video. What I want to focus on today is, in this topic of software and system software, is the role of operating system software, and in particular process management. So a common GCSE question is one that looks a bit like this. So it asks about the operating system, and it wants to know how scheduling is used to allocate processor time to different processes. And there's a large number of key terms here that we need to understand. So we need to know what the role of the operating system is. We need to know what they mean by scheduling. What's a process, and how is it that it is allocated processor time? Okay, let's briefly recap the role of the operating system. So the operating system manages the hardware that you are using, the physical components that make up your computer, and it manages the software that is running on that hardware. You can see it sitting in the middle of this stack here. Now, applications like a word processing application, or Teams, or email, or maybe you're browsing the internet, or maybe you're playing a game. So the user is using an application. That application is interacting with the operating system, and the operating system is able to manage all the different hardware that is in your computer. And if you think about it, if your application, say we were browsing the internet, if it had to know and be able to cope with the different kinds of CPU that you can use, or whether you've got 4 gigabytes of RAM or 8 gigabytes of RAM, or is it DDR3 RAM or DDR4 RAM, or are you using a solid state hard drive, or are you using a hard disk drive? You know, the browser, the application, it doesn't care what your hardware profile is, because the operating system can deal with all of that. And it means that the application doesn't have to be this massive, humongous program that takes ages to load and goes out of date really quickly. All it has to do is work on Windows 11, for example. So in an office environment or a school environment, you're probably using a Windows 11 OS, unless you're using an Apple Mac, in which case you're probably using iOS, or maybe you're using the open source Linux software. But let's assume for a second it's Windows 11. So the browser interacts with the operating system, is designed to work with the operating system, and it doesn't have to worry what hardware you've got on the computer. So now we know what an operating system is. What is meant by processes? So processes are basically the instructions that applications generate when they are running. So let's again assume that we are searching something up on the internet using either the Chrome browser or the Edge browser, and when we do that, when we open that app up, it generates processes that then are sent to the CPU. So process management and this question is basically about the topic of how the CPU and the operating system manage a flood of processes that come to the CPU and are queued up, because it's not just the in our example the browser app that's running. You've also got lots of other things running on that computer. So if a printer is connected to the computer, it might be printing something. It might be that you've got antivirus software running on that computer. The operating system, in just the moment-to-moment operation of the computer, is generating processes. So how does the operating system schedule this flood of processes to decide how much processor time each process gets and in what order the CPU sees them? Okay, so finally, let's look at the answer to this question. So how does the operating system schedule processor time to different processes? Okay, well, they all go into a queue, and each process is given a small amount of time called a time slice. Okay, so that is, remember, a CPU is running at billions of processes a second. A 1 gigahertz processor can process 1 billion instructions per second. So a time slice is a tiny amount of time that is allocated to a process. Hey, you can use this much CPU time before you get booted, okay? So that means that the process has a certain amount of time, and if that instruction gets finished and it's completed, that's great. But if it's not finished, it gets put back into the queue, and then it circles round to have another go later. So let's assume you're working on a computer. You've got several apps open. You're browsing the internet, you're playing a game, you're listening to some music, and you've got a messaging app open as well. Okay, and it looks like this computer is managing all of these applications and allowing them to work all at the same time, and that's what is meant by multitasking. Okay, but let's assume it's a single core processor, and we know that a single core processor can only carry out one process at a time. So would you expect it to pause the game, play a bit of music, and then stop, and then do one thing at a time in a very jittery way? Well, no, because this is all happening in billionths of a second. So by giving a time slice, by queuing up processes and giving a time slice to the process generated by this app, it will carry out that instruction, and then it will move on to instructions from a different application and carry out those processes, and then it will move on to a different app, and it will move on in a cyclic way, giving a time slice to a process and then allowing it to multitask. And it is the operating system that queues up these processes and decides how much time each app should have and which app should have priority. Okay, so we're nearly there, and hopefully you are now able to answer most of these questions. You know, a process is generated by the app running on a computer, and those processes are queued up in so that they can be given CPU time. Okay, and it is the OS, the operating system, that manages those processes and decides what order they are going to be seen by the CPU and how much time they're going to have. So that's what a time slice is a process is given a certain amount of CPU time in order for it to be processed, and if it runs out of time and the process hasn't completed, it actually gets booted to the back of the queue, and then it comes back for a bit more CPU time in a few billionths of a second. And you know, that is a complex process where deciding which processes get to be at the front of the queue and how much of a time they should get, that's all managed by a scheduling algorithm. And we go into more detail about different forms of algorithms that follow different rules, but at GCSE you don't really need to know that. You just need to know that a scheduling algorithm decides how much time is allocated to the process and what order the processes are going to be seen by the CPU. and that scheduling is managed by the OS. Okay, now what we haven't really talked about is the role of the interrupt. So your computer is going about its business, minding its own business, and maybe you're printing out something. Okay, now if you don't have a way of managing what happens when the printer runs out of paper, then the computer will crash. You need to design these applications so when the printer runs out of paper, they can send a message to the operating system saying, well, hold on a second, something unexpected has happened. Okay, and then the operating system can stop what it's doing and then decide what to do with this information. And what it's likely to decide in this scenario is pop up a message on your screen saying printers ran out of paper, and it will pause the printing process. Okay, now it'll then carry on doing all the other things that it's queued up, but it's just let the run out of paper process jump the queue, because if it didn't, something would be happening and it hadn't planned for it, and that could crash the computer. So hopefully now you can answer questions like these and GCSE questions like these, and hopefully you are getting a better sense of the software topic, and that application software is one branch of software, system software is the other branch. We've been looking at operating system software, and in particular at process management, which involves scheduling, a process algorithm, time slice and interrupts. And we will look at utility software and these other activities in a different video.